Hello everyone, welcome to day 19. Today I'll be doing this overlapping interval problems. Intervals are often manipulated through sorting and merging based on the start and end time. We'll start with the first question. Merge intervals. Given an array of intervals where interval I is start I, end I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So if this is the input, what we are doing is 1 3 2 6. So these are overlapping, so we will do 1 6 and then 1 3 and then 2 6 8 7 is missing, so 8 10 and then 15 18. So these are not overlapping to anything, so 8 10 and 15 16. In this, these two are overlapping, so we'll have 1 5, and in this 1 4 4 7, so we are 1 7. Okay, so basically we have to return an array where we need to return all the overlapping intervals. Fine. So one way of doing this would be that we take an array of size, we take the max value in this, max is 18, right? And then we create a array of size 18, and then we start iterating over this array, and at each index, so let's say this is the interval, so we'll make all the elements which are between this interval as 1 in the array or true. Let's keep it as a boolean array, and in this array we'll make array 1 as true, array 2 as true, and array 3 as true, and so on. So for each interval we will check this array and update all the digits or indexes with these interval present between them as true. And then once we are done with all the elements, then we will iterate over this array and check the intervals, we find the intervals where there is consecutive true, and then return the interval. This will take time complexity of order of n square, because we will iterate over this one, so order of n, then and at each for each index we are iterating over this array again, so n square. And along with that we are also taking extra space of size order of max value of this, which is 10 to the, which could be n. So this is not a good approach, but this is a brute force solution for this. The other way of doing this would be it is not sorted, right? It is not sorted because in this we haven't given a sorted array. First of all, we should just sort this, so this will become like 1 4 and then 4 7. So first of all we should sort the given array by the first element or the start element, and then what we can do is we can check side by side if they are overlapping. So once this is sorted, we can check if these two are overlapping. Let's say 1 4 4 7, this is overlapping, so this will be the result 1 and the start of this and end of this, so 1 7. Let's take this example and see if it works. In this case it is already sorted, right? 1 2 8 15. Now we check that if these two are overlapping. So they are overlapping because this value is greater than this value. If this value is greater than this value, that means they are overlapping, right? So we will take start of this and end of end of the second one, so 1 6. Now we cannot skip this, and we should check that if this is overlapping with the next one. It is not, because there is space between 6 and 8. 7 is missing, so this is not overlapping. That's why we will put it in the result. Now it is not possible that it will be overlapping with any other value, because it is less than 8, it will be less than all the other values, so this will be inserted in the result. Now next is this. We'll check if this is overlapping with this. It is not, because this is smaller than this, so this will be added in the result. Similarly, this will be added in the result. One more case could be that what if here we have only two values, and here we have 10, and here we have 2 6. In this case the answer is not 1 6, rather the answer is 1 10. Okay, so in this case if we check that this is greater than 2, so that means they are overlapping. But in the result we shouldn't be inserting 1 6, rather we should be inserting 1 and the bigger value between these two, so 1 and 10. So the algorithm will be like, we initially take a current which will be the first element, or the element we are currently comparing, so 1 3. Then we compare current with the next element and see if it is overlapping. If it is not overlapping, then we insert this current into resultant array. Otherwise we keep comparing. So we compare it with this, it is overlapping, so we update current as 1 6 and we insert it, and then we don't insert it, then we compare current with this one. If it is overlapping, then we update current. If it is not overlapping, then we insert current, insert rest.add current, and then we move on accordingly. Fine. I think this is fine. I'll write the code now. They are asking to return integer, but we are not sure of the size of the the size of the resultant array. We cannot create it right away. Let's create a list and then we can so list of integer I need to store two values. The first thing is we should be sorting this, so we can use the inbuilt sort method of arrays dot sort, and then sort intervals in such a way that if a and b are given, then we need to compare it like this: integer dot compare a0 and b0. Need to compare it by the first index or the start index. So this is now sorted, and we can take result. So let's say list of, we need two values, so we can take list of int array. We'll take a array result equals to new array list. Okay, and then in first we also take a current, so int current equals to new integer of size 2, and current equals to interval 0, intervals 0, current equals to, so current is now the first element. Now next is we need to compare it with the, start comparing from next element. So int I equals to 1, I is less than intervals dot size, sorry, intervals dot length, it's a array length I plus plus. Now we need to compare the adjacent ones. So we'll compare current with the first one, and for that we need to compare that if this is greater than or equal to this, then they are merging. We need to compare that if current 1, if current 1 is greater than intervals I 0 greater than or equal to, then we need to merge. If this is the case, then we need to merge. So current equals to, if this is the case, then current will be then current 0 will remain same, right, the smaller one, but current 1 will update. So current 1 will be math.max of these two, integer.max or math.max, math.max java, math.max, math.max of these two, so this and this, the greater in these two. So current 1 and intervals I1. Okay, so we have compared these two and we have got the overlapping interval, we have updated the overlapping interval, and if they are not overlapping, then else what we do, we insert the result dot add current, and we also update current to intervals I, and at the end also we need to insert, because one will be left, and then we need to return it as a this thing. So we'll take int equals to new int result equals to new int of size 2 and size result dot size, and then for what happened? Intervals, it is intervals. Integer dot compare. Okay, I'll test one more case. What if we are given only one element? What will happen in that case? Is not valid. Okay, fine, submit it. Cool. In this case the time complexity is n log n, because we are sorting here, so sorting will take n log n, and this will take order of n, so time complexity is n log n, and space is order of n. We'll move to the next question. You are given an array of non-overlapping intervals where this represent the start and end of ith interval, and intervals are sorted in ascending order by start. Now this is already sorted. You are also given an interval new that represents the start and end of another interval. Insert the new interval into intervals such that intervals are still sorted in ascending order by start, and intervals still does not have any overlapping interval. Merge interval if necessary. After the insertion, note that you don't need to modify intervals in place. You can make a new array and return it. One, 2, 3, 10, 12 16 25 1569. Okay, so initially also it is not overlapping, they are saying in the question they are not overlapping, but after insertion we need to check if they are overlapping or not. This will get inserted here. So in such cases we need to check it with the previous one and the next one. One thing is, if it is not overlapping with, if these two are not overlapping, it is quite simple, I think, that in this case this will get inserted somewhere here, right? Here it will get inserted, but the question remains that then we can check if find the overlapping, and then similar to previous question we can return. But the question is, do we need to check only the overlapping between these three, or we need to check it in the whole array? If we insert something here, is this going to make it overlap with this or this somehow? Let's try to figure it out. 4 8 is given, so it gets overlapped with this 8 10. Okay, so we need to check it with all the numbers. One more easier way could be that first we can check where it lies, okay, by checking the starting index, so it lies here, and then after that we can check where 4 lies. 4 is less than 5 but greater than 3. Four is greater than 3, so it is overlapping with this. If it was greater than 1, but it is greater than 3, it is greater than 2, so it will never overlap with this, it will only overlap with this. Similarly, in other side we'll check 8. 8 is greater than 7, 8 is less than 10. अगर यहाँ पे 9 होता, इस केस में ये ओवरलैपिंग नहीं है इसके साथ, इट इज़ ओनली ओवरलैपिंग विद दिस, राइट? सो वी विल स्किप दिस. So that means we are not checking just with we are not checking just with the end, we need to check it with this index as well. If it is equal to or greater than, if it is equal to or greater than the start index, if it is equal to or greater than the start index, then we need to check. Okay, I got it. So basically what we are doing for finding the overlapping on left side, we'll compare 4, and we'll compare 4 with this value. If it is less than this value, then we can check the next one. If it is greater than this value, then it is not overlapping. and then we will take the overlapping between these two, and we'll take the smaller element between these two. So this is 3 to 8. Similarly, on this side we compare this with the start value. If this is greater, we compare this value with the start value. If this is greater, then we compare it with this. If it is greater or equal, then we compare it with this. It is not, so then it stops here, and we take the bigger value between these two. Okay. Let's put everything in a list first, and then we can what we can do is we use the same algorithm which we did earlier. We just update this interval. So let's take one more intervals, n equals to intervals dot length. Okay, and then when we take one more array, interval equals to let's take some of the intervals v2 equals to new int, and we'll take variable size n plus 1 because we need to insert one element, and 2. Now for int I equals to 0, I is less than n, I plus plus, and we also take a variable int j equals to 0. Now if new interval new interval dot I dot new interval is only of 2 this size, right? Only one element is there, 0 and 1. So new interval dot 0 is greater than I0. If it is greater, this value is greater, then we'll put interval in the array. So d2 j0 equals to interval I0 and 1 equals to interval I1, else if it is less, so 2 is less than 6, 9. In such cases, we'll insert new interval in this. Let me try to print it and see if what I've written is correct. Int I equals to 0, I is less than n plus 1, I plus plus system dot out dot println intervals v2 I 0 plus space plus intervals v2 I 1. One 3 2 5 6 9, and in this case 1 2 3 5 4 8 6 7 8. So insertion is done. Now what we did in the other question, we can just do that again. Sorting is not required. We'll just do this again, and instead of using intervals, wherever we are using intervals, we'll use intervals v2. Oh, by mistake I clicked on submit. 1 second. Now I'll submit it. Okay, if n equals to 0, in that case we just need to return n equals to 0. Then in such cases we just need to return that one element. So intervals v2 I 0 equals to new interval return intervals v2. And let's try this test case. Now what is this case? 1 5 is there, then 2 7. Output is 1 5, expected is 1 7. Let's try this also. Interval is this, and we are given 2 7. We are given 2 7. After insertion, let's print I equals to 0, I is less than n plus 1, I plus plus system dot out dot println intervals v2 I 0 plus space plus intervals I 1. How is this out of bound? Intervals v2 is of size n plus 1 and 2. Oh, it is intervals v2. One 5 and 0 0. This is not correct. So initially when I equals to 0, in new interval 0 is 2 is greater than this, so this will get inserted. Okay, so that means if this is at the end, then it is not getting inserted. So basically what was happening is, in this case, if the interval needs to be inserted at the end, then that case was not working because this loop was never running, and that's why the new interval was not getting inserted. So this is done. That's all for today.